In our second section, we're going to talk about some more things. Now, in the second section, we're actually going to delve directly into Venn diagrams. The first thing we're going to talk about what Venn diagrams and this specific notation actually means. So we'll talk about two sets, A and B, A union with B. So that's that terminology that we had in that first section. That is our union. It means something that's in one thing and or the other. So a union of A and B is talking about everything in this circle as well as everything together with whatever's in this circle. Whereas if we talk about the intersection, when you have two circles, it should be pretty obvious as to what an intersection is, but it really is using the word and, whereas a union uses the word or. Intersection is talking about and, so it has to be in this circle and in this circle. Well, it's talking about just that overlap in between. Now, this is a special one that you'll be seeing slightly. I have it in different formulae and such, but basically it means but not. So the way that we read this is it's in A but not B. In order to properly say that, then we be talking about everything that's in circle A, but it's not in B. So it makes kind of that Pac-Man shape. And then disjoint sets are two sets that have absolutely nothing to do with each other. That's exactly what that is. A Venn diagram is just a visual representation of grouping and organizing information, specifically anything that talks about sets. So our first example. Now, we do offer, but obviously there's some cases where we don't do these. At Grenfell High, we offer a large variety of extracurricular opportunities. Largely, we offer many different sports as well as do many sports during intramurals or during our phys ed classes. So we have a few different classes, a few different things. We have volleyballs, badminton, all of these. What we're going to do is we're going to determine the number of sports that require the following types of equipment. The first one is a ball and an implement, such as a stick, club, racket. One's a ball, an implement, not ball. But we're going to have two sets. We're going to have one set that talks about a ball and one that uses an extra implement. So to play volleyball, well, to play volleyball, you need a ball. Now, when we're talking about implements, we're not talking about the net or anything like that. So it's something that just needs a ball, but it does not need an implement. Badminton does not need a ball. Badminton just uses implements. Even the birdie is not a ball, so it's not a ball. Archery. Archery is something that only uses implements. Arrow, bow. Curling. Curling does not use a ball. It's just an implement. Softball. Softball is something that uses a ball and an implement. So it will be in our intersection. It needs the ball and needs the implement. Now, continuing everything else, basketball, you need a ball. Beyond that, you don't really need anything. Golf. Golf, you need a ball, but you also need clubs. So it needs both. Wrestling. Wrestling doesn't need a ball or an implement. It's completely non-handed combat. So it's still part of our entire universal set, but it's just not part of these. It's not going to be part of our Venn diagram. Ball hockey. Obviously, it needs a ball, but it also needs a stick. Football, it definitely needs a ball, but it doesn't need any kind of extra implement. Track and field, by definition, it doesn't use anything unless you're talking about the track being needing the field stuff. So like your javelin, your discus, your shot put. Shot put is not a ball, it's just a big hunk of metal, so it's not really a ball, but it needs an implement, but it doesn't need a ball. Cross country running. Doesn't need anything. Cross country. And dodgeball. Just needs the ball, doesn't need anything else. So here's what we're going to do. We have a total of, let's see, 13 sports. We're going to determine the number of sports that require the following types of equipment. So a ball and an implement. The way that we would say that is a number for a ball and an implement. So that's that keyword, and. Needing a ball and an implement is going to talk about the intersection. Ball and implement. We can simply count that up. It's 4. Or sorry, ball and intersection 3. Sorry, I apologize. How we need only a ball. So the way that we'd say that is a number that would need a ball but not an implement. And that's 4. An implement but not a ball. That would be talking about an implement but not a ball. That one's these 4. Either a ball or an implement. So the number ball or is a key word. Or means the union. So it's going to be using that symbol, the U. Ball or an implement. It's talking about everything in here. So that's 4, 4, and 3 works out as 11. Neither a ball nor an implement. I was going to use some terminology that we used before. So ball or an implement, but it uses the complement. It uses that apostrophe. So it's saying something that doesn't use a ball or an implement. That's 2. That's just wrestling and cross country. How many are in? And then 2 last things. Ball. It doesn't say only a ball. It talks about the entire circle. How many sports use a ball? And that's 7. Same thing. Number of implement for implement. That's talking about the entire circle of implement, which is 7. So that's what all of that means. Keep in mind what the terminologies are. And let's talk about these. So this is the equation for, it's principle of inclusion and exclusion. It's basically an equation that says, okay, this is what can be done. The number in A and or B equals the number in A plus number B, subtracting the number in A intersection with B. Overall, what it does is it says this. If you take all of this and add all of this, you can see that there's this intersection that would be shaded in twice. I'll just make that a little more obvious. Because it's shaded in twice, if you take out one of them, it means that it would only be talking about everything that's in these circles, which is what this is. Remember that symbol being or, this symbol meaning and. If you take out that intersection, it's just talking about just what's in there. Now there is another way of saying it. And I'll just say you don't really need it. You don't even need to write this down. But I just like to say, just for the sake of it, there's another way of writing this entire equation. I won't even bother giving it to you just because it's not really needed. But if we took just the part that's just in A but not the intersection, that's talking about this. In A but not B. If we added the number in B but not A and added the intersection, that would be the same thing. This is just another way of writing the equation, but this is the one that you're going to use. Oh, sorry. Use this one. All right. Question. In an Alberta school, there's 65 grade 12 students. Of these students, 23 play volleyball and 26 play basketball. There are 31 students who do not play either sport. Let's solve it. Let's represent this using a Venn diagram. So obviously I'm missing a few words. In a Venn diagram. Okay, so in Alberta school, there's 65 grade 12s. Okay, so that means that everything here needs to add up to be 65. Of these students, 23 play volleyball, 26 play basketball. So let's call A volleyball and B basketball. It's just going to make our lives easier instead of me saying A is volleyball and or yeah, instead of using it the other way. So let's look at this terminology. The number in A union with B. That's talking about everything that's in these circles. That's not 65. It says 23 play volleyball. This is basketball. So the entire circle of volleyball play is 23. The entire circle of basketball is 26. But we don't know exactly how many are in this intersection. That's where this number is going to help. It says 31 don't play either. That means there's 31 that are still in grade 12, but don't play volleyball and they don't play basketball. We don't know how many are in the intersection. So by chance, if we took 23 and subtracted x, we'd find out how many are just playing volleyball. Same thing, basketball. If we took 26 and we subtracted x, we'd find out how many are just doing basketball. So let's use this equation to help us. There's a number in A union with B. Well, we have to talk about how many are totally in these circles. That's actually really easy to do. There's 65 total in this entire set, this universal set. But by subtracting 31 who don't play either sport, oh, sorry, I want green. This is saying that there will be only 34 student athletes. And A, how many are just playing, or how many play volleyball together? Well, that's 23. How many play basketball? 26. How many are playing both? because the sports don't really have a lot of overlap. It's an unknown. So by finishing off our stuff, 23 and 26, do 49, subtract x, and then some quick manipulation and solving. Subtract 49 over, and 34, subtracting 49, should be 15, well, negative 15. That equals negative x. Now we have to get rid of the negative, so divide by -1. So saying that x is 15, which means that then there will be a total of 11 that just play basketball and a total of 8 that just play volleyball. And if you take 8, 15, 11, and 31, add it all up together, it equals 65. Now let's take a look at this one. Morgan surveyed 30 students in her math class about eating habits. 18 students eat breakfast. 5 of the 18 also eat a healthy lunch. 3 students don't eat breakfast and don't eat a healthy lunch. How many students eat a healthy lunch? So we'll talk about breakfast and a healthy lunch. The equation would then be number in breakfast union with healthy lunch would equal the number that eat breakfast, add the number that eat a healthy lunch, subtracting the number that eat breakfast and a healthy lunch. Let's fill in what we have. So it says that 18 students eat breakfast. So this entire circle here needs to be 18. 5 of the 18 also eat a healthy lunch. Great. Okay, that's awesome. We can do that right away. So 5 are already eating a healthy lunch. That means that there would be 13, which is just the 18 subtract 5. That would eat just that breakfast. Says that 3 students don't eat any breakfast and don't eat lunch. So that 3 would have to stay on the outside. How many eat a healthy lunch? Well, that's what this question is asking about, this entire circle. There's a few quick ways. Obviously, the fastest way would be just taking 30, subtracting 13, subtract 5, subtract 3. We get, what, 9? That should be right. Yep. Our final answer, though, how many students eat a healthy lunch? 14. Because it's 5 plus 9. I just want to draw yourself back to the equation, just because we're going to have to be really comfortable with it for our next section. How many have breakfast or a healthy lunch? Well, that would be 30 subtract 3. As it says that 3 don't eat either. How many eat a good breakfast? It says 18. We don't know exactly how many are eating a healthy lunch, but it says 5 of 8. So if we had whatever x plus 5 will give us just that healthy lunch. And then by subtracting, how many eat breakfast and a healthy lunch? Well, that's talking about 5. 5 eat healthy lunch and breakfast. Combining our like terms, 18, add x, add 5, subtract 5. Well, the 5's cancel off, so we would just have 18 plus x. Quick solving, subtract 18. And our unknown is 9, which means to answer our question, 5 plus 9 is 14. If a question was worded like this, I wouldn't care which way you solve it. but you just have to be very comfortable with using the equation. As well, make sure you know how to use x as a variable. It's nice and easy. Alrighty, have fun.